Good day. I'm Mikael Sepe from BSIS 1A, Tribe 1 Algebra. Our topic is all about variables. Variables is something sometimes taught as a mathematical genre because we can use it as a placeholder. So what is variable? Variable is a symbol that represents an unknown value. It is represented by a letter like X or Y. We can also use any letters, but the X is the most that we commonly use. We use a variable every time we talk about something we imagine to have one or more values, but we don't have any idea what they are. So this is the example. Is there any number with the following property? Doubling it and adding 3 gives the same result as squaring it. In this sentence, we can use a variable to replace the word it. Is there a number x with the property that 2x plus 3 equals square? This is how we represent the given statement using variable. We can also use a variable every time we want something to be equally right for all elements in a given set. So this is another example. No matter what number might be chosen, if it is greater than 2, then its square is greater than 4. In this sentence, we can use a variable to maintain the majority of the statement. No matter what number n might be chosen, if n is greater than 2, then n squared is greater than 4. A variable allows us to give temporary name to what we are seeking, which help us to perform a concrete computation in order to find its possible values. The variable also ensures that the possible confusion will be avoided. How will you compute if di mo naman alam ang isosolve mo? That's why we can use variables to represent the unknown value so that we can go on a computation using variable.
Good day everyone, I am MJP Turalba from BSIS 1A. The topic for today are the 3 statements in math. The first one is called universal statement. What is universal statement? Universal statement says that a certain property is true for all the elements in a given set. For example, let B be the set of all species of non-extinct bird, and B be a predicate variable such that B. The second part is conditional statement. What is conditional statement? In conditional statement, if one property is true, the other property should be true. This statement has 2 parts. The first one is hypothesis, if, conclusion, then. For example, if P then Q, where P and Q are sentences, for this conditional statement, P is called hypothesis, and Q is called the conclusion. Intuitively, if then Q and P means that Q must be true whenever P is true. The third statement is called existential statement. What is existential statement? In existential statement, there is at least one thing, which is the property is true. It expresses the existence of at least one object which has a particular property. For example, there is a positive integer that is less than or equal to any positive integers.
Good day everyone, my name is Erica B. Villahen from BSIS 1A Tribe 1 Algebra. So today I am going to discuss the combinations of the statements and how we can rewrite it in a various ways. So first, the first combination is the universal and conditional statement. The universal and conditional statement is a combination of universal and conditional statement. The universal statement contains the variations of the word for all, while the conditional statement contains the versions of the word if then. For example, for all animals, if A is a dog, then A is a mammal. Note that the most important fact about the universal conditional statement is that it can be rewritten in a way that can make them look like a pure universal. For example, for all dogs A is a mammal, or all dogs are mammals. We can rewrite the statement and make it look like as a pure universal statement. We can also rewrite the statement as a pure conditional statement. For example, if A is a dog, then A is a mammal. Or if an animal is a dog, then the animal is a mammal. We rewrote this statement and make it look like more conditional statement. The second combination is the universal existential statement. The universal existential statement is a statement that is universal because its first part says that a certain property is true for all the objects of a given type, and it is existential because its second part asserts the existence of something. For example, every real number has an additive inverse. In this statement, the property has an additive inverse applies universally to all real numbers. Has an additive inverse also asserts the existence of something, an additive inverse for each real number. However, the nature of additive inverse depends on the real number. Different real numbers have different additive inverses. Knowing that an additive inverse is a real number, you can rewrite this statement in several ways, some less formal and some more formal. For example, all real numbers have additive inverses. Or for all real numbers R, there is an additive inverse for R. Or for all real numbers R, there is a real number S such that S is an additive inverse for R. The last combination is the existential universal statement. An existential universal statement is existential because its first part asserts that a certain object exists and is universal because its second part says that the object satisfies a certain property for all things of a certain kind. For example, there is a positive integer that is less than or equal to every positive integer. This statement is true because the number 1 is a positive integer and it satisfies the property of being less than or equal to every positive integer. We can rewrite this statement in several ways, some less formal and some more formal. For example, some positive integer is less than or equal to every positive integer, or there is a positive integer m that is less than or equal to every positive integer. Or there is a positive integer m such that every positive integer is greater than or equal to m. Or we can also write it this way. There is a positive integer m with the property that for all positive integers mn is greater than or less than to n. We can also write this statement in several ways, some less formal and some more formal. For example, some positive integers is less than or equal to every positive integer. Or there is a positive integer m that is less than or equal to every positive integer. Or there is positive integer m such that every positive integer is greater than or equal to m. There is a positive integer m with the property that for all positive integers n, m is greater than or equal to n. That's all. Thank you.
Good day, ma'am. I'm Carmencita J. Kaido, BSIS 1A, Tribe 1 Algebra. My topic is language of set. The word set is a formal mathematical terms introduced by George Cantor. A set simply means a collection of elements. For example, kung ang C ay set ng lahat ng countries that are currently in the United Nations, then United States is an element of C because United States is currently part of United Nations. And if I is a set of all integers mula 1 to 100, then ang 57 ay elements ng I.
Hey everyone, I'm Bantayan J. Samay from BSIS Tribe 1 Algebra. My topic is a set roster notation. Roster notation of a set is a simple mathematical representation of the set in mathematical form. In the roster form, the elements or members of a set are listed in a row inside the curly brackets. If the set contains more than one element, then every two elements are separated by a comma symbol in a roster notation. Example, if A is the set of the first 10 natural numbers, so it can be represented by A is a set that contains the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let R be the set of all vowels in the English alphabet. R is a set that contains element A, E, I, O, O.
Good day, Mom. I'm Maria Cleo Fibulalin Briseño for BSIS 1A, Tribe 1 Algebra. So, the topic is all about ellipses. The ellipses, the three dots are called an ellipsis. We use an ellipsis in the middle of a set as a shortcut for listing many elements. For example, let is be the set of all letters in the English alphabet. Describe this set using roster notation. S equals braces A, B, C to Z. Note, the number of elements in a set S is countable, so each of these sets is a finite set. A finite set has a finite number of elements. So, let S be the set of all English alphabet. Describe this set using roster notation. The element of S is written as braces A, B, C to Z. Because we have many number of elements and writing, it all embraces will use a lot of space. For example, let T be the set of all whole numbers. T equals braces 0, 1, 2, 3, 4, 5, 6, and so on. We use an ellipsis at the end of the list to indicate that the set goes on forever. Set T is an infinite set. An infinite set is a set with an infinite number of elements. It is not possible to explicitly list at all the elements of an infinite set.
Hi guys, my name is Erica P. Balares from BSIS 1A. Ang topic na i-discuss ko is part siya ng language of set, which is the set builder notation. For example, was the set A. It is read as set A is the set of all x is a natural number between 5 and 10. Ibig sabihin ng mga elements na dapat lang nasa set ay mga natural number between 5 and 10, which is the 6, 7, 8, and 9. Sa ganitong paraan, hindi na kailangan pang ilista kung ano ang mga elements ng set gaya nito. Ang advantage kasi ng set builder notation ay what if the given sets has a more number of elements like 20 or above. Kung gagamitin ng roster notation, which is the other way of writing a set, mas komplikado at mahaba na ang set.
Good day, Mom. My name is Catherine Joy and Bidran from BSIS 1A, Tribe 1, Algebra. My topic is all about equal and equivalent sets. When we have two sets that have exactly some elements, we call them equal sets. It doesn't not matter what order that elements are in. It just matters that the same elements are in each set. Here are some examples of equal set. Elements set A is all about 1, 3, 5, 7. And the elements of set B is all about 7, 5, 3, 1. Equal set are the set with exactly the same elements and cardinality. The example of equal set is the definition of equal someone or something with the same quantity or value. An equivalent set is simple. It is simple as set with an equal number or elements. That set do not have to have the same exact elements, just the same number of elements. Let's take a look of some example. Element set A is equal to A, B, C, D, or E, while the set B is the January, February, March, April, May. Even though set A and B have completely different elements. Set A comprises letter and the set B comprises months of the year. They have the same amount of elements, which is 5. Set A contains 5 letters and set B contains 5 months.
Hello guys, welcome sa aking presentation. I'm Marvin Jim Nonsol of BSIS 1A. Para sa discussion natin guys, joint set ang ating i-discuss. Ngayon, tara guys, discuss na natin to. So, ano ba guys ang joint set? Ito ang sets na at least one common set or one common object sa kanilang dalawa. At least one lang. Example AM, A, E, O, U. E, sunod naman E equals to LOVE, love. There's an element set M, set E, which are common. Kapag may common dalawang set, tawag sa kanila joint sets. Parang may dugtungan silang dalawa, may kakapareho. Yun ang joint set. Okay guys, kabaliktaran niya naman, disjoint sets. Disjoint set, wala siyang common element. Ibig sabihin, wala silang dugtungan. Example A, P is equal to plus minus sign X at divide sign. Q is equal to red, blue, green. There is no elements in sets P that are the same to sets Q. Sabihin, walang pagkakapareho. Yan ang tinatawag na disjoint sets. Okay guys, tandaan nyo na. Okay, sunod guys. Are the following sets joint or disjoint? S equals to COVED. T equals to VIRUS. J equals to Luzon, Visayas, Mindanao. Yung K naman 1, 2, 3, 4, 5. Ito ang sagot dyan. Sets S and T are joint sets kasi may pagkakapareho silang dalawa, which are I ang pagkakapareho nila. Number 2, sets J and K are disjoint sets because they have no common elements. Tingnan nyo naman, wala naman number yung Luzon, Visayas, Mindanao. Okay guys, remember nyo lang yun. At yun na nga guys, sana naintindihan nyo ang simple presentation. Salamat.
Good day, ma'am. I'm Manuel Alvarez Para from BSIS 1A from Tribe 1 Algebra. Today, I'll be explaining my topic about relation. A relation is a rule that relates values from a set of values called domain to a second set of values called the range. The elements of domain can be imagined as input to a machine that applies a rule to these inputs to generate one or more outputs. A relation is also a set of ordered pairs X and Y. Relation can also be found in our daily life, like people are related to each other in many ways. Like for example, parents to children, teachers to students, employer to employees, and many others. The other example of relations can be found in scenarios like this. Places you can drive to with 1 gallon left in your gas tank and the number of calories in a fast food hamburger. And those are some of examples of relations that we may encounter in our daily life. Thank you.
Good day, ma'am. I am Christine Herno from BSIS 1A, Tribe 1 Algebra. So, my topic is about the relation as a subset. A relation is defined as a subset of A cross B. The domain of a relation is the set of elements in A that appear in the first coordinates of some ordered pairs. And the range is the set of elements in B that appear in the second coordinates of some ordered pairs. For example, let A is equals 1 and 2 and B is equals to 1 and 2 and 3, and define the relation R from A to B of as follows given any y and x and y is an element of the product of Z and A and B. So x and y is an element of relation R. It means that x minus y over 2 is an integer. Let's answer the question. Number 1. State explicitly which ordered pairs are in A cross B and which are in R. So to get the product here, it is 1, 1, 1 and 2, 1 and 3, 2 and 1, 2 and 2, 2 and 3. So, all of these ordered pairs, we will have to substitute this and the given statement one by one. So, they will only become an elements of relation R if their output is an integer. 2 and 1 is not an elements of relation R because 2 minus 1 over 2 is equal to 1 over 2. And 1 over 2 is not an integer. 2 and 2 is an elements of relation R because 2 minus 2 over 2 is equals to 0. And 0 is an integer. And lastly, 2 and 3 is not an elements of relation R because 2 minus 3 over 2 is equals to negative 1 over 2, which means it is not an integer. Knowing all of this means that the elements of relation R is 1 and 1, 1 and 3, and 2 and 2. So, to know if 1 and 1 is an elements of relation R, we need to compute 1 minus 1 over 2 times 1 minus 1 over 2 is equals to 0, which means that it is an elements of relation R because 0 is an integer. We will only repeat this method to know if the following ordered pairs is an elements of relation R. 1 minus 2 over 2 is not elements of relation R because negative 1 over 2 is not an integer. 1 and 3 is an elements of R because 1 minus 3 over 2 is equals to negative 1, means that it is an integer. Let us now move to question 2. Is 1 related to 3? Is 2 related to 3? Is 2 related to 2? The answer in the question is 1 related to 3 is yes, because 1 and 3 is an elements of R. 2 and 3 is not related to each other because 2 and 3 is not an elements of R. And lastly, 2 is related to 2 because 2 and 2 is an elements of R. For the final question, what are the domain and range of R? So, in the first question, our x values are 1 and 2 and our y values is 1 and 2 and 3, which means that our domain is 1 and 2 and our range is 1, 2, and 3.
Good day, ma'am. My name is Ira Jane Bernal from BSIS 1A student, Tribe 1 Algebra. My topic is all about function. Function is a relation where each element in the domain is related to only one value in the range by same rule. The elements of the domain can be imagined as input to a machine that applies a rule so that each input corresponds to only one output. A function is a set of ordered pairs x and y, such that no two ordered pairs of the same x value but different y value. This is a function can be represented in different ways. Number 1, a table of values. Number 2, ordered pairs. Number 3, graph. And number 4, an equation.
Domain and range of functions. Domain. The domain of a function is the complete set of all possible values of the independent variable. When finding the domain, remember, the denominator bottom of a fraction cannot be 0. The number under the square root sign must be positive in this section. How to find domain? In general, we determine the domain of each function by looking for those values of the independent variable, usually x, which we are allowed to use. Usually, we have to avoid 0 on the bottom of fraction or negative values under the square root sign. Range. The range of a function is the complete set of all possible resulting values of the independent variable y, usually after we have substitute the domain. How to find range? The range of a function is the spread of possible y values, minimum y value to maximum y value.
Good day. I am J. Corativo from BSYS 1A Tribe 1 Algebra. My topic is vertical line test. The vertical line test is a graphical method of determining whether a curve in the plane represents the graph of a function by visually examining the number of intersections of the curve with vertical lines. How will we know that a relation is a function using a vertical line test? Not function. It is a not function due to the fact that the single vertical line drawn intersects the curve in 2 points. Function none. It is a function because of the vertical lines drawn intersect on the curve in more than 1 point.
Good day everyone, my name is Mark Antonio Prepanaria from BSIS 1A Tribe 1 Algebra. Now I'm going to discuss about mapping diagram. Mapping diagram shows how the elements are paired. It's like a flowchart of function, showing the input and output values. A mapping diagram consists of 2 parallel columns. The first column represents the domain of function f, and the other column for its range. Now the question is, how to know if a relation is a function using a mapping diagram. Example number 1. It is a function because the x values only have 1 y values. This pair is called 1-to-1 pair. Example number 2. It is not a function because x values paired with more than 1 y values. This pair is called one-to-many.